Alright, so now I have my tools here. Let's go. I'm going to use red. So let's go and read the equation one more time. So it says 6x minus 2 times the quantity of x minus 5. Once again, this is negative 5, okay, equals 64. 46. So where's my eraser? There it is. So notice what happens here. It says first I would C. Apply the distributive property. So I would apply distributive property. Use my smart cut here. Use a smart cut here. Apply that out. And my invisible uno that we know here. So the amount of negatives, odd amount of negatives. So that's going to give me, and 1 to the 2 is 2. So negative 2x. Done with that. Then we go over here, one negative sign, a second negative sign. That's an even amount, 2 plus. And then 2 sets of 5 is 10. And I'm going to bring down my 46 and bring down my 6x because I didn't mess with them. So I hope that makes sense. So first I would C. What would I do? Apply the distributive property, as you noticed here. Then I would B. What? Combine like terms. So let's do that. Alright, remember the rule about like terms here, right? Base is the same, x and x, parts are the same, invisible uno, invisible uno. So then I have the difference of 6 and 2, or 6 positives, 2 negatives, leaves me with 4 positives, or 6 minus 2, or the difference equals 4. So 4x plus 10 equals 46. Alright, so first I apply distributive property. Then after that, I combine like terms. Then it says after that, I would what? And it says A, apply inverse operation. Okay, so if I have 10 positives here, well, then how many negatives do I need to get to 0? I need 10. And what I do on one side, I do on the other. Those of you that like arithmetic, how to undo addition? By using subtraction. And then I go over here, the difference of 46 and 10 is 36. Or 46 positives, 10 negatives, 36 positives. So 4x, I'm looking pretty good. So let's go through our checklist again. To solve this equation, first I would C, apply distributive property. After that, I would B, combine like terms. Then I would B, combine like terms. After that, I would what? A, apply inverse operations. And then finally, I would E, divide the remaining variable's coefficient by itself. The remaining variable here is 4x, and I do what I call an eyeball check. What do I see as a coefficient of my eyeballs is 4, so I divide by 4. Little FB baby right there, and over there, little FB baby. Remember, same 4 there. Then how many sets of 4 and 36? You got it, 9. So you can see how this all kind of plays out. Unfortunately, because this is here, you can't see the x equals 9 that you put. So this is how I'm looking for you guys to lay these out when you start doing these in formative, okay? You'll do your work on a piece of paper, and then you'll go to formative, and you'll type out first I would, put the appropriate letter, then I would, and so on. So make sure you write down these sentences because you'll be needing them in formative, okay? All right then. So let's clear some of this up, erase it. Boom, gone. Okay, so let's go on to, I'm going to go ahead and close this for now. Let's go on to the next slide. So let's take a look at this in action with some equations to make sure that you understand this. This is probably one of the simpler equations that we have, but I want to make sure that we went over all equations so people could understand, all right? So let's go here. I have the equation 5x plus 3 equals 23. You could also see it this way. 5 times some number plus 3 is going to be the same as what? 23 here. All right, so let's look at it. So if I use my paper, I would say first I would what? Well, it looks like I would A. Apply an inverse operation. And notice this time I'm using it on integer numbers, okay? Can I use it on variables as well to do, applying an inverse operation? Yes, but notice. So 3 negatives there, 3 positives, 3 negatives, or 3 minus 3, how you like that. We do on one side of the equal sign, we do on the other. So notice, I'm down to 20. And then I would what? I would go ahead and apply the old FB, baby. So divide the remaining variable's coefficient by itself. So there's only this variable here. What's the eyeball check say? It's a 5 as a coefficient. Divide by 5. What I do over here, of course I do over here as well. And then last but not least, I have I have 4 is my answer. And so notice I only used 2 letters here when I was explaining how to solve this equation, all right? All right, let's press on. So these are pretty basic equations, and because of that, we're going to kind of go through the next one. This one is interesting, so I do want to talk about this one because this can be challenging, and it was for some students. Let's take a look at this challenge here. So this challenge is 21 minus t equals 11, or 21 minus some number equals 11. So what do I do first here? First I would what? A. Apply an inverse operation. This time it's not variables, it's integers, it's numbers, but yeah, we can do that. And so notice what I'm left with that I bring down here is negative t. We know by now that we cannot have a negative t. For this equation to be fully solved, the variable must be by itself with a positive invisible uno. So what I do here is I go and say, and finally, I would divide the remaining variable's coefficient. It's the only variable left by itself. And remember, invisible uno, so I divide by -1. That's going to give me the positive invisible uno of 1. But notice here, one negative sign, the second negative sign, an even amount, positive 10. All right. Let's go on to the next one. Oh, look at that pen. On to the next one. So you can see there's relatively the same types of equations. Okay. What I want you to do right now is, and I think we did some of these yesterday. I want you to do, last week. I want you to do number 4 and I want you to do number 5. And then we'll pause and go on to the next one. So now we're moving on to some equations that are a little different here. We talked about these, but I still want to go and make sure you understand. If you look at these equations here, they're a little different because guess what? I got a variable on this side, got a variable on this side, got a number on this side, and got a number on this side. So when we get here, we got to start making some choices. Like, what side do I want to have the variables on the equal sign? Which side do I want the numbers on, the integers on the equal sign? So over here, you can already tell that it looks like I chose variable on the left and numbers or integers, whatever makes you happy, on the right. So as I look at this, and I want to solve this equation, my first sentence would be, first I would, let's see, looks like I would do A. Apply an inverse operation. Looks like I have 6 positive here, 6 negatives, done with it. What I do on this side, of course I do the same thing over here. So I had 6 negatives over here, and do 6 negatives over here. Let's do a little throwback arithmetic. The difference of 10 and 6 is, you got it, 4. Okay, so we have that there. We didn't mess with the 9 or the -9. We'll make sure you understand that. So we bring that down. That's gone. Bring down our 3, and we're here. So at this point, I've done A. And that when I did the A, notice how I did the A let me get that negative in there, using variables. But down here, do I use variables? Nope. I'm now applying the inverse operation for a second time, but this time on numbers. 9 negatives, 9 positives, 0. The same action or operation I did on that side, I want to do over here. So 3 positive, 9 positives gives me 12 positives. I bring down my 4h because I didn't do anything with it. And then we're at what? And finally would be my sentence. I would go here, divide the remaining variable coefficient by itself, and notice the remaining coefficient right here is h. So we'll wind up, FB baby, little FB baby over here. We'll wind up, and you can't see it, but you obviously know that the value x is going to be 3. So let's go ahead and erase. Take a look at a couple more examples here. So close out. Take a look at this one here. Once again, A, E. Notice A, E, A, E. So we kind of notice what's happening applying inverse operations. We're going to end this video and we'll go into our last two different types of equations that we're going to be working on, okay? All right, so let's end this.